You can see my screen, right?
Yes, sir.
Okay, fine. Okay, so in this session, basically we'll revise the concepts of week 7 and 8. So let me start with sequence. So can one of you tell me what is sequence? Any idea?
Week 7 is starting from some topics from Math 1.
Okay, so that basically you have already studied, but
Yes, sir.
yeah.
After that, function of one variable. After that,
So what you want to say? I didn't understand.
I'm just saying the lecture's name, sir.
Yeah, so then?
So we can revise according to lectures as we do before.
So these are the concepts of basically you have studied multiple times, right?
Yes, sir.
So then what is the point of revising all the concepts? Already we had revision session on these concepts, right?
Right.
Yeah.
So limits of sequence and
Yes.
limits.
Yeah. So yes, that is what I am asking. What do you mean by sequence?
Sir, an is sequence if small n belongs to natural number.
So sequence, okay. Sequence is basically it's a map from the set of all natural number to R. And how you represent this sequence? You represent this sequence by this notation. And for each values of the natural number, you have a real number, right? So you have A1, A2, A3, and an plus 1, and so on. Okay, so you have a infinite list of numbers where these indices are coming from the natural number. So this is the first term of the sequence. And this is the nth term of the sequence, and similarly you can say that this is the n plus 1th term of the sequence, and it's basically it's going till infinity, right? And what we are interested to find the limit of the sequence, right? And what is the meaning of the limit of the sequence?
Limit should be exist. If exist, it's convergent.
So limit is basically mean, so when I can say that the limit of the sequence is A, right? So when I can say that the limit of the sequence is A, if all the terms, okay, so if I increase the value of n, if all the terms of the sequence are going closer and closer to A, right? If all the terms of the sequence are going closer, if I have a number A, right? If I have a number A, so that all the terms of the sequence are going closer and closer to A, in that case, I say the limit of the sequence is precisely A. If I don't have such number A, right? If I don't have such number A to which all the sequence are going closer and closer, all the terms of the sequence are going closer and closer to this A. Okay, if I don't have such number A, in that case, I say that
Divergent.
yeah, divergent or limit doesn't exist. Okay. if I have no such a, in that case, I say that limit doesn't exist. So let's take an example. The easiest one, let's say this is my sequence, right? So this is a sequence, right?
Yes, sir.
So if I consider the terms of the sequence, what I am getting, 1, 1 by 2, 1 by 3, 1 by 4, right? So on. Right. And if you increase the value of n, then you can see the terms of the sequence, they are basically going closer and closer to 0, right?
Yes, sir.
Yeah. So that means the limit of the sequence is, so in this case, the limit of the sequence is 0, right? So I can write limit n tends to infinity, 1 by n is 0, right? And suppose if I take one more example, let's say, suppose my sequence an is -1 by n. Then what will be the first term of the sequence? What is the first term of the sequence?
-1.
-1, sir.
Yes, -1, then 1.
Again, -1.
Yes.
Yeah.
Right. So you have some kind of alternating pattern you are getting, right? So the first term you are getting -1, then you are getting 1, then you are getting -1, then you are getting 1, right? So you have this number line, and this is your -1, this is your 1, right? And if you increase the value of n, then what basically happening? So the odd terms of the sequence, they are basically going towards -1, and the even terms of the sequence, they are going towards 1, right? So in particular, all the terms, they are not approaching to a fixed number, right? So bunch of terms, they are approaching towards -1, and other terms, they are approaching towards 1. So I don't have a unique k in this case, right? I don't have a unique k to which this sequence is approaching as n tends to infinity. I have two such numbers. So in that case, what I can say, the limit doesn't exist, right? So limit doesn't exist. Clear?
Yes, sir.
Yes, sir.
Yeah. So let's take one more example. Let's say my sequence is, let's say n square plus 7n plus 5, then 2n square plus 9n plus 1. What will be the limit of this sequence?
1 by 2, sir.
Yeah, so you are correct, 1 by 2, but how I can get it?
By dividing
By
it
taking
by
common n
n
square.
square, right?
Correct. Both of you are correct. So if I divide n square both in numerator as well as in the denominator, right, I will get this one divided by 2 plus 9 by n plus 1 by n square, right? And as n tends to infinity, what will happen to this thing in the numerator?
7
by n and 5 by n square tends to 0.
Correct. This will go to 0, this will go to 0, and as a result, the whole thing will go towards 1. And similarly, by the same logic, this will go to 0, right? This will go to 0, and as a result, the whole thing will go to 2, right? And now the whole thing, right? The whole thing will go towards 1 by 2, right? So the limit of the sequence is 1 by 2.
Yes, sir.
Yeah. So the next question is, if I consider this sequence, okay, what will be the limit of this sequence? Any idea?
First we rationalize and then we get the limit.
Correct. Correct. Yeah. So, yeah. So, obviously, what will be the proper way of rationalizing it?
Root 2n multiply by root 2n plus 1 plus plus root 2n. We multiply these and divide by this.
Correct. So,
And in numerator, we get the formula of a square minus b square.
correct. So, if I do that, then what I will get? So, this is nothing but this is equals to 2n
2n
plus
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 1
1
minus
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 2n.
2n.
Yes, sir.
So, now
2n cancels 1 by root 2n plus 1 plus root 2n.
So now it's really easy to deal with, right? So as n tends to infinity,
1 by n to 0.
as n tends to infinity, this thing will go towards what?
0.
0. No, no. If it goes to 0, then it will be undefined.
1 by infinity.
1 by infinity will go to 0.
Yeah, so this
Yes,
will
sir.
go
zero.
towards infinity,
Infinity and
and
entire
and,
thing will go to 0.
yeah, as a result, the entire thing will go towards 0, right? The whole thing will go towards 0.
Excuse me, sir.
Yes.
Yes, sir, sir. In any sequence, n always tends to infinity.
Yeah, that is, see, so when we are actually checking the limit of a sequence, right? So if you go back and see what basically we wanted to know. So as n tends to infinity, where the sequence is going, right? That is the main idea. So when we are dealing with a sequence, when we are trying to find the limit of the sequence, what basically we are trying to find? As n tends to infinity, where the sequence is approaching. Okay, so by definition of the limit of the sequence, we have to always take that n is going towards infinity. Okay.
Okay, sir.
Yeah. Right. So in this case, this is the limit of the sequence. Okay. So next, let's take this sequence. Okay. So this is slightly different. So how I have defined my sequence? If n is even, then this one represent the term of the sequence. If n is odd, then this one represent the term of the sequence. So for example, if n is 1, then what is a1? A1 is 10 minus 1 plus cos 1 divided by n, right?
I'm sorry, sir.
Sorry,
I think, yeah, you
The
correct.
uppercase we will take.
otherwise, yeah.
Yes, sign 1. Yeah, because n is odd. So, and similarly, a2 is 20, right?
10n.
Sir, in A1, it will be 10 plus 1.
Yeah.
Divided by 1, right?
I made a lot of mistake. Okay. So A2 is 20
Minus
minus
1
1
plus cos 2
cos 2
divided by 2.
divided 2, and so on. Like, yeah, you can similarly you can find the other terms of the sequence. Now, what we want to find as n tends to infinity, where this sequence an is approaching, right? This is the whole idea. So as you can see, if so So if n is odd and n is going towards infinity, okay, in that case, where this term of the sequence will go?
First one.
10, sir.
10.
But
10.
so 10 by n plus 1 plus sine n by n, right? So this I can write as 10
N by n.
plus 1 by n
Sin n by n.
n, right? So as n tends to infinity, this is clearly this
Ze-
is going
zero.
towards 0. What about this one? Sin n by n?
1,
All
sir.
1.
0.
Not 1, it will goes to 0, 0. Yeah.
0.
Yeah, why?
Because if limits n tends to 0, then it will be 1, but it n tends to infinity, it will be 0.
N, see, the problem is, okay, so when I'm writing actually n, see, when actually I'm writing as n, so n actually here, what basically mean? It's a natural number, right?
Yeah.
Right, sir.
What is the meaning of n tends to 0 when I'm talking about natural number?
Not possible.
See, when I'm talking about natural number, there is no meaning of this n tends to 0, right? Because
Right, sir.
see, because you have only natural number. N tends to 0 means n is precisely 0, right? N is exactly 0. Okay, so if n is exactly 0, then this is not defined, right?
Yes.
So for natural number, there is no concept of n tends to 0. Okay, so I can say that, so that is what. So I can say that n tends to infinity. So for example, if I take, let's say 1 square, 2 square, 3 square, okay. So this basically tends to infinity. Okay.
Yes,
So
sir.
this has some meaning. So when my domain is basically natural number, in that case, this n tends to 0 has no meaning. Okay. Okay, so now tell me, as n tends to infinity, what will be the value of this sine n by n?
1, sir.
1,
So
sir.
0. So 0.
0,
And-
sir, 0.
Yeah,
n
it's
tends to infinity or
Instant-
0?
0, sir.
0,
See,
0.
see the
0 it will be.
yeah. So why?
Sir,
Because,
because n tends to infinity, so it will value will be very large, and then it becomes 0.
Yeah, so
Sine grows slower than n. So
yeah. So basically the reason is sandwich lemma, right?
Yeah.
So this is always sine
Minus 1.
n is always less than 1,
minus.
right?
Yes, sir.
Right?
Yes, sir.
So as n tends to infinity, this thing is going towards 0, right?
Yeah.
And
1
this
by n
is also
also
going
goes
towards
towards 0.
right? And the thing in the middle should also go towards
0.
0, right? So as a result, the whole thing will go towards
0.
yeah, the whole thing will go towards 0, and in the term, this thing will
10.
go towards
10.
10.
Sir, we can also say that, like, if the n at the denominator, if it is getting bigger and bigger, then the overall value will become smaller and smaller. It will tends to 0. Correct?
Yes, so correct, but the thing is also it matters what is there in the numerator, right?
But sir, if it is in the numerator, anyways, if in the denominator, if in the numerator it is a constant, right? And in the denominator, if we have
It's not okay, it's not constant, but in some sense it's bounded.
there must be some value, right? There must be some value. But in the denominator, if we have infinity, then at the denominator, the value becomes very large, so that the overall value will reduced. It becomes very small. So actually, this concept I have learned in the video only.
No, I still don't agree what you are saying. So the thing, what actually I'm trying to say, yeah, you can say that you have something in the numerator.
Yeah.
Okay. See, this is not constant. right? The sin n is not
Yeah,
constant.
it's
If you
not
keep
constant, that's my mistake, but there must be some value, right? And then when we
No,
divide
even-
with a very large number, then it
no,
becomes.
that is what I'm saying. Instead of sin n, okay, if you plug n square, okay, whatever you are seeing, the same thing holds for n square as well, right?
Yeah.
But if I divide this by n, then this will not go towards 0, right?
Yeah, because so that's not possible.
Yeah,
n square by n.
yeah, so the main reason what I am trying to say, whatever is there in the numerator, okay, this is sort of bounded. Okay, this sin n is sort of bounded in, it's basically in between -1 to 1, right?
Okay.
It can't go beyond -1 to 1. Okay, and whereas whatever you're saying for the denominator, whereas the thing in the denominator, it's going towards infinity. It's
Yeah,
too
it's
large.
not bounded. Yes.
Yeah.
So,
So that's
yeah. So in that case, then it will be.
yeah. So it's nothing special about sin n, right? If you take cos n as well, okay, in that case also you
It
can
will
say
be-
it will go towards 0.
Zero.
Yes.
Yeah.
So it's depend what is there in the
Numerator.
yes.
Sir, for all trigonometric values, can we say that it is bounded between -1 to 1? Like for tan and cos and cot.
No. Tan n is not bounded, right? Tan x is an unbounded function, right?
That means, sir, in any generalized way, you can say for any bounded function, if n tends to infinity, it will lead to 0.
Yeah, suppose you have, instead of sin n, you have some f of n,
Right, which is bounded.
which is bounded, right? Which is bounded, and if you divide n, right, then this whole
It will lead
thing,
to 0.
yeah. So because see again, the same idea. So if it is bounded, then basically it should be less than some m by n,
Right.
and it should be greater than some minus m.
The
by
minus m by n.
And
Okay.
sir, if it is tan n by n, then it will be infinity by infinity, right?
Yeah. So in that case, actually, you can't conclude anything.
Yeah, then we cannot say it is 0. It's infinity
Yes.
by infinity, indeterminate form.
Yes.
Okay.
So
Eh?
just sin n, sir, like only sin n when it tends to infinity
Sin n.
or cos n.
So yeah, so this it's easy, right? So it's sort of you have some sin n is sort of oscillatory function, right?
Yes, sir.
So if you take basically n towards infinity, this limit doesn't exist. Okay.
Okay, sir. Yes, sir.
Same thing will happen for cos n as well.
Yes,
So
sir.
yeah, so this is the case when n is odd, right? And if n is even, by the same procedure, you can say that if n is even, because again cos n is bounded, right? Cos n divided by n is also going towards 0. So if n is even, n will go towards 10, right? You can do that, right? By the same procedure, right? And as you
Yes,
can
sir.
see, so it doesn't matter whether n is odd or n is even. Both the cases, your an is going towards 10, right? So as a result, the limit of the sequence is 10. Okay. Any doubt from question number 2?
No, sir.
Just one question, sir. In case these odd and even do not match, means they do not have same value, can we say the limit do not exist? This sequence
Limit doesn't exist. Okay, so in that case, what you have? You have so basically, as if you keep increasing your value, okay.
Right.
So you have bunch of numbers, right? If you take the odd numbers, right? So they are approaching to some let's say 10, okay. And whereas if you keep increasing the even numbers, they are, let's say, approaching to 12, right?
12.
So in that case, all the terms of the sequence, okay, they are not approaching to some fixed number, right? That means limit doesn't exist.
Right.
Yes.
Sir, I had a small doubt. Like you said, cos n tends to infinity, that is divergent, right? Limit. So tan n is also divergent. What about other trigonometric functions?
Most of the cases, I guess, most of the trigonometry function will diverge. Okay, because tan n, I'm not sure, but most likely it will also diverge. Okay, because it has some weird properties. So first of all, this is not tan x is not defined on whole real line, right? Because you have
multiple supply.
yeah, so sort of the graph is more or less like this, right? So this is the asymptote. Okay, and you have this repeating pattern. Okay, most likely I can see. Okay, so if you take it will diverge. So, but yeah, one needs to prove it formally.
Okay, sir. Thank you.
Sir,
Yeah.
can you please explain one more time what exactly the converges and diverges means? Sometimes I get confused.
See,
Sometimes it is, so converges means it tends to, right?
yeah, it's see, the one and only meaning of convergent is you have some. So suppose you have a sequence, right?
Mhm.
So convergent means you have a number. We have a fixed number, okay,
Mhm.
to which all the terms are approaching.
Okay, that is converges.
That is convergent. If
And
this
sir,
is
if
if
they
this
say
is
divergent, then
if this is not the case, then if you have some different meaning apart from this one, then the rest cases are divergent. Okay.
sir, yesterday actually I also understand the same thing, but yesterday I came across one question in that it was written it diverges to infinity. So what does that mean, diverges to infinity? Because every time we do, like, it converges to infinity, like it tends to infinity, and then
No. It's actually, yeah. So if see, the tends to infinity means kind of same meaning. Okay. So when actually infinity comes, in that case, you always say the sequence diverges. Okay. So for example, when you are talking about limit, right? So when when you are getting limit x tends to 0, some function, okay, this is infinity, right?
yeah.
So in that case, what you say, limit doesn't exist, right?
Mhm.
So the same thing is happening here. So for example, if I have a sequence like this, let's say I have a sequence an, okay, this is a sequence, right? So as n tends to infinity, this an is what, where it's going towards infinity, right?
Yes.
So it's true that an is actually going towards infinity. A is approaching towards infinity, right? But in this case, I say that
Divergent.
this sequence diverges.
Okay. Okay.
But I can't say such kind of things here, right? If I have a sequence like this, okay,
Yeah.
so I don't have this sort of scenario here, right? So here I have two things, okay, to which the sequence is approached, right? I have -1 and I have 1. Right?
So, sir, what is this? Is
Again, this limit doesn't exist. Okay.
doesn't exist.
Yeah. So
Yeah, of
here
course not. It's
yeah.
not
So
clear.
here the only extra thing you can say that an diverges to infinity. Okay. That is the only difference. But still here the limit doesn't exist. Okay.
Yeah. Okay, sir.
Yeah. Okay, so the next, okay, let me, so you have any specific doubt regarding limit? Anything else you want me to talk? Okay. Hello?
No.
Yes.
Yeah. Doubt, sir.
Sorry?
No doubt, sir.
Okay, fine. Yeah.
Excuse me, sir. Sir, properties of limits.
Sorry?
Yes, sir. Properties of limits, like formula, like limit of e to the power x plus 1 upon n as x approaches 0 equal to something. This is properties.
See, property of limit is not that. So limit is additive, limit is multiplicative. So these are the property of it. So you
It's a
don't.
formula, sir. This property not the formula, like
Which formula?
Like
Okay,
sir,
so that you don't have to remember. If it is coming, then mostly will give you the result. Okay, you don't need to remember some different formula. Okay, you just need to remember the rules of the property, rules of the limits. Okay, that limits are basically this, right? This is additive.
okay, sir. Yes, understood, sir. This is
Yeah,
understood.
so this, of course, this you can apply if both the limit of an
Okay,
and
okay,
bn
sir.
exist.
I
Okay,
already
and
know.
yeah. So the apart from this, so you are talking about, there are a lot of question in your activity part where you need to know the limit, right? So for example, if you take this one, okay, it's given in the question, right?
Yes.
Yeah. So we'll not expect you to remember all these things in your exam. Okay, if something is coming, then we'll provide you this.
Okay, sir.
Okay.
Okay, sir.
Because yeah, so the proof is not easy. Okay, so yeah, so next thing is your limit of function. So how you compute limit of a function? Suppose you have a function, let's say, okay, let me take the simplest one. Suppose you have a function from R to R, right? And you want to talk about the limit of the function. Okay, limit of the function at some specific point, right? So you want to talk about limit of the function at some specific point. So how you can compute? What is the normal procedure of computing the limit of a function at some point?
So firstly, simplifying the equation, then putting the limit. If right hand limit exists and left hand equal to,
Yes, so
then limit will be exact.
yeah. So the first thing is, first you need to compute the left hand limit, right?
Yeah. Yes, sir.
Let's say you have a left hand limit. Let's say you have a left hand limit, right? So what is basically the left hand limit? So you need to check. You need to check if you are coming to a from the left hand side, right? Where this value of this function is approaching. Okay.
Yeah.
So where this value of this function is approaching. Okay. So this will basically gives you the left hand limit, right? And how you compute the right hand limit?
We will come from the right side.
Correct. So this is your left hand limit, and for the right hand limit, you have to come from the right. Okay. So when you are coming to this point from the right, you see where the value of the function is approaching. So in that case, if you have some value, in that case, you say this is the
Limit.
right
hand limit.
And if your left hand limit and right hand limit matches, okay, if the left hand limit is same as the right hand limit, in that case, you say the limit of the function at x equal to a limit of the function at x equal to a exists. Right. So for example, let's say, okay, so let's say if I take a function like this, let's say I have a function like this. So this is 1. Okay. So this is included. And let's say this point is 1,5. And after that, this point is, let's say,
1,4.
I can't say this is 1,4 because I have already written
Okay. Okay. Sir.
1,5. 5. Okay, this is a number different from 5. Let's say this is okay, so no problem. I can write this as, let's say, 1, 3. Okay, but the value of the function at 1 is 5. Okay, the value of the function at 1 is 5. So this is a function. F of 1 is 5. Okay, not 3. Sorry, f of 1 is 5. Okay, this is not in the domain of the function. Okay, so at 1 the value of the function is 5. So if I talk about the left hand limit, what will be the left hand limit of the function?
5, sir.
5, right? So when you are coming to 1 from the left hand side, right, the value of the function, as you can see, it's basically going towards this point, right? And this is precisely 5, right? So the left hand limit is 5, right? And what will be the right hand limit?
3.
3, sir.
3.
This is 3, right? So in this case, what is basically happening? Both left hand limit exist, right? And as well as right hand limit exist. Okay, but the problem is they don't match, right?
Yeah.
So that's why the limit
Not exist.
doesn't exist. Okay. Suppose you consider one more example. So let's say this is some point 3, and you have a function like this. Sorry. So this is asymptote. This is asymptote. And at 3, let's say after 3, the value of the function is some constant. And let's say this is 3, 7. And this point is, of course, included. So for this function, what will be the left hand limit?
3.
Do not exist.
3 not exist, right?
Yeah, so in correct. So the left hand limit is, if you compute, this is basically as x tends to 3 minus, if this is my function f of x, this is precisely minus infinity, right?
Yes, sir.
So that means the limit doesn't exist. Okay, the left hand limit
Doesn't exist, right?
So if the left hand limit doesn't exist, from there itself, you don't have to compute the right hand limit separately. From there itself, you can say that the limit itself doesn't exist, right?
Yes, sir.
And again, like if you want to compute the right hand limit, then from the picture, it's clear that the right hand limit is 7, right? Because the value of the function at 3 is 7. So if you are coming to 3 from the right hand side, this is precisely 7, right? But
yes,
to talk about the limit, this is enough, right? If my if one of my limit doesn't exist, so either if the left hand limit doesn't exist or right hand limit doesn't exist, from there itself I can say that limit doesn't exist, right?
Yes, sir.
Yeah. So okay, so now you take this example. Can one of you tell me what about this function? Let's say I'm talking about the limit of the function at x equal to, or what will be the behavior of the limit of the function at 2?
The limit does not exist.
Why?
Because if we take limit from the left hand side, then it will give us 2. But if we take limit from the right hand side, then it will provide us 5 only. So the left hand limit and right hand limit are not same.
Correct. So let's say this is the graph. This is 5, right? And this is the graph of the function, right? So this is certainly not included, this point, because x is 5. Sorry, f of x is 5 if x is strictly greater than, right? And this point is included, and this is your line. What? It's given, right? F of x equal to x.
Yes, sir.
Right. So once you have this figure, from here you can say that if I'm coming to 2 from the right hand side, then this is precisely the value of the function, right? This is 5. So that's why the right hand limit is 5. And when you are coming to 2 from the left hand side, the value of the function is going towards 2, right? So the left, so both left hand limit exists, both left hand and right hand limit exist, but they are not equal. Okay, so that's why your limit at x equal to 2 doesn't exist, right? So if, let's say, before going into this next question, let's say you have a function f of x equal to mod x, right? So what about the limit of this function at x equal to 0?
That doesn't exist.
Doesn't exist, sir.
No, why this is doesn't exist?
Derivative doesn't.
Yes, sir. Yes, sir. It exists.
Yes, sir.
Derivative doesn't exist.
Zero.
Yeah, the derivative doesn't exist.
Yeah, it
Okay.
exists. Both tends to 0.
Yeah, so when
Tangent doesn't exist.
yeah,
Exist.
yeah, that means the derivative doesn't exist. So when you are coming to 0 from the left hand side and right hand side, the value of the function is basically coming to this point 0, right?
Yeah.
So limit
It is
exists.
continuous.
Yeah.
Yes.
The limit exists, yeah. So even you can say that this function is continuous as well.
Mhm.
But
Sir,
yeah,
I have a question in this. Sir, if any function is continuous, sir, let's say this question only, right? Then this is continuous, right? And if we said that x tends to 0, then why can't we say that the function is defined at 0? Why can't we say like that?
no, this function is defined at 0, right?
Sir, actually, I have a doubt. It's the same question, the similar question. So it's in activity 8.1, where the question is if limit x tends to a, f of x is equal to L. In that, the first option is f is defined at a, and that option is not correct. I'm not getting that one, why it is not correct.
So I'll come to your question. Let me after that continue. Yeah, no. Sandwich lemma. Okay, so let me address this question. So the thing is, so limit, when you are talking about limit, you don't need the condition that the point is inside the domain of the function. Okay, so suppose I have a function. Let's say I have a function from 0, infinity to r, right? And how I define this function? F of x equal to x, right? So it doesn't matter. So again, you can extend this function to whole r, but for the way I have defined, 0 is not inside the domain, right? 0 is not inside the domain of the function.
Yes, sir.
Right, but still I can talk about the limit. Okay, still I can talk about the limit of the function. Okay, so what basically I'm trying to find when x is approaching towards 0, right? when x is up. So here, since my domain is precisely 0 to infinity, okay. So this is my domain. Right?
Sorry.
Sorry. Hello.
Yes, sir. Limit extends to 0 fx. After that, your voice is breaking.
Yeah.
No,
So
sir, is clear.
No, clear.
yeah. So what I'm trying to say, so 0 is not inside the domain of the function, but still I can talk about the limit of the function at x equal to 0. So the only thing what I need to check so here, this is my, the domain is precisely this one. Okay. So what basically I need to check, as x tends to 0, where this value of the function is going. So, okay, I don't need the condition that x is equals to 0, right? So when I'm saying x is approaching towards 0, the only thing so when I'm saying that x is approaching towards 0, x may not be equals to 0, right?
So we
Correct.
can only find right limit here.
Yeah, in this case, you can only find the right limit. Okay, and that is precisely the limit of the function at that point. Okay. And if you want, you can slightly modify this function. If you want to find both the left hand limit and right hand, you just remove this point. Okay, so then the domain is precisely this. Okay, apart from 0. Okay, so in that case, you can also find the left hand limit and right hand limit. Okay, but
One more case we can take. If we have 0, then we have some other values of that function, like 3.
No, in that case, 0 is inside the domain, right? So basically C asked when I'm talking about the limit of a function at some point, that doesn't imply that point should be inside your domain. Okay, that is
okay.
So here 0 is not inside the domain, right? But still I can talk about the limit of the function at x equal to 0, right?
But
this
so
is
like it is continuous, and if it is defined that the limit exists at 0, then we will consider from both the sides, right? We will not consider from one side only.
no, when you are talking about continuity, right?
Mm-hmm.
But when you are talking about continuity, in case of continuity, that point should be inside your domain, right? You can't talk about the continuity of a function at some point, and that point is not in your domain. See,
Yes,
what you need for continuity,
the limit should exist from both the side, right? And at
both
that point also.
both the sides, and this should be equals to
That
f of
point.
0, right?
Yes.
So when I can talk about this thing, when I can find the value of the function at that point, when this point is inside the domain, right?
Yes, sir.
Yes.
So when I'm talking about continuity, okay, at some point A, okay, that means this A should be inside the domain of the function.
Yes, sir.
Right. But I don't need this sort of condition for limit, right? I just need to check where this value of the function is approaching when I'm coming towards that point. Okay, from both the direction. Okay. I don't need the value of the function at that particular point when I'm talking about the limit.
So, sir, at 0, the function is not continuous, right? Because the point you cross, limit extends to 0.
Yeah, here there is no concept of continuity as the function is not defined. Okay, so then there is, I can't talk about the continuity.
Yes, sir.
Yeah.
But sir, if it is given like limit, like you write here, right? Already the limit extends to 0 f of x, right? And it is given that only this thing is given, which is equal to L, let's say. So what will you say? This function is continuous or not? If it is, if the question has asked like this only, whether it is continuous or not.
Which one? This function
extends to 0.
So for this function?
No, just this.
The part you written in red color, sir.
No, not in the red color, in the black. Limit extends to 0 f of x is equal to L. Then what will you say? This thing is continuous or not at f? At f is continuous at 0 or not?
So the f is this one, right?
Sir, it is not given in the question.
Then how, see, if nothing is given, then how you can talk about?
So this is the question in activity 8.1.
No, tell me then which one is the question? Then there must be some problem in the question, right?
Sir, activity 8.1, question 1.
Can you repeat 8.1, right?
Yes. And question 1. So the question is, if limit x tends to a.
Let's
Yeah.
say the question. This is the question, right?
Yes, sir. Sir, I'm not getting this.
Yeah, so that is what I'm trying to say, right? So what basically it's saying, the limit of the function at x equal to a is L, right?
Yes, sir.
So I said I can talk about the limit of the function at some point, even if that point is not inside the domain.
Yes.
Right? So if this is given, okay, that doesn't mean that f should give some value at point A. That means it doesn't, so it's not necessary that a should be inside the domain of the function.
Sir,
Right?
if we take that condition, like just now you said the not necessarily be in the domain, right? That means it should, if it is not in that, then f is not continuous, correct?
No, f is not continuous. That I agree.
Sir, the option is f is continuous at a. One of the correct option.
I think it's not correct.
It's not correct.
No, it's not correct.
No, nothing.
Okay, so only one option is correct. Okay.
See, the limit, given that this is L, that means only thing I can say that the left hand limit and right hand limit same. Okay. Apart from I can't say anything about.
Okay, so then I got it. It not necessarily be like at a it is continuous. So if it is not continuous, then we cannot say that a is defined in f.
Yeah. So to talk about the continuity of a function at some point, the point should be inside the domain of the function. Okay. But for limit, I don't need such type of condition. Okay.
Okay. So if it is continuous at a, that means f is defined at a.
Yeah, because for continuity you need this condition, right? F of a. Okay, and I can talk about this f of a only when a is inside the domain of this function.
Okay, sir. Sir, thank you. I got it now.
Okay, so yeah, so this I guess you can easily do this question. Okay, so so do you want me to solve this question? I guess you must have.
No, sir, we can do this.
No.
Yeah. Okay, so the next crucial part is
sir, before going to that, in the previous one, in the previous one where one left hand side goes to minus infinity and right hand side was this one. So let's assume that right hand side is also going to minus infinity. Then can we say that it is that the limit exists?
No. See,
it should be finite.
You can actually compare the limits, right hand limit and left hand limit, when they are finite. Okay. If they are going to infinity, minus infinity and minus infinity, still you can't say anything. Okay. In that case, see, when one limit is going towards plus infinity or minus infinity, okay, that means that particular limit or left hand limit or right hand limit, that limit doesn't exist. Okay. Yes. So if one of the left hand limit and right hand limit doesn't exist, that means the whole limit doesn't exist. Okay.
So one thing here, how you are writing this, it goes to minus infinite. I'm unable to see this in graph.
So when you are coming to 3 from the left hand side, right?
Okay.
So where this function is going? This function is going, right?
It will never cross the 3 or touches the 3. So that's why continuously going downward.
So it's continuously it's going downward, right?
Okay, so actually I was thinking this approaches to 2 or something. So how it goes to infinite?
No, this is going to 3, right? 3 minus.
Okay.
So when you are coming to this, see, this is at this 3, this is a asymptote, right? And this asymptote is basically going downward, right? So when you are coming to 3 from the left hand side, the value of the function is going down, right?
Yes, sir. Minus
towards
infinity.
minus infinity.
Yeah, get it.
Okay, so yeah, so again the idea is same sandwich principle that you have studied in limits, and the same thing is also true for sorry, what you have studied in sequence, the same thing more or less true for limits as well. So what basically says, suppose you have a function f of x, okay, so this is a function, and the limit of the function at x equal to a is, let's say, L, okay, and limit, and you have one more function g of x, and the limit of the function at x equal to a is also L, okay, and if I have one more function which is basically in between these two functions, okay, so if I know these two things, okay, if I know this limit and this limit, then I can easily compute the limit of this function at x equal to a. And this sandwich theorem precisely tells that this limit is L. Okay, if this limit is L, right, and this limit is L, then the limit of the middle one is also L. Okay, so now if you know this fact, can you tell me how I can solve this question by applying the sandwich theorem? Any idea?
By taking range of
cos
cos.
x lies between -1 and 1 and multiplying, right? Yes.
Cos x, correct. The approach is correct.
This function is always stays in between -1 and 1, sir.
Correct. So yeah, so someone asked, right? So if you see, actually this function is not defined at 0, right?
Yes, sir.
Not defined at 0. Okay. But still I can talk about the limit. Okay. So this is in between 1 to -1, right?
Yes, sir.
So then what is the next?
Multiply by x square.
Yes, sir. Multiply x square.
Correct. So if I multiply x square is always positive, right?
Yeah.
Yes, sir.
So if I multiply, then certainly it's not going to affect the order of the inequality. So this is x square cos 1 by x, right? And you know, as x tends to 0, this is going towards 0, right?
Yeah.
Yes, sir.
And this is also going towards
0.
0. So that means the thing in the middle should also go towards
0.
0, right? So then I can say that limit x tends to 0, f of x is 0, right? And if I modify this definition, let's say if I modify this definition, so this is precisely when x is not equal to 0, right? Because at x equal to 0, this is undefined. Right. So if I modify this at x equal to 0, this is 0. In that case, I can say that since the limit is 0, in that case, I can say that the function is also continuous at 0, right? Because this is same as f of 0. Because I have extended this function to whole R. Okay. Any doubt so far?
Sir, I face problems when these signs of inequality changes. I don't know when these signs of inequality changes. Can you give some example?
No, see, sorry, you are saying when this changes, right?
Yes, sir. Yes, sir.
See, the thing is, okay, depend what you are multiplying, right? See, suppose you have, don't think as some, so this, see, when you are writing this inequality, okay, this is just a combination of bunch of inequality, right? So you can write this as cos 1 by x, right?
Yes, sir.
And also you can write this as cos 1 by x less than equal to, right?
Yes, sir.
So forget about all these things. Suppose you have an inequality like this.
Okay.
So if you multiply 2, right?
Hmm.
2 is positive, right?
Yes, sir. Yes,
So
sir.
if you multiply 2, then this will preserve the inequality, right?
Yes, sir. Nothing changes.
But if you multiply -2, what will happen?
Minus 2a.
Sign reversed.
See, when you are multiplying minus, see, 1 is greater less than equal to 2, right?
Okay. Yes, sir.
If I multiply -2, what I will get?
Minus 2, minus 4. So
-2, -4, right?
yes, sir.
So now what will happen?
The sign changes, sir.
Sign changes, right?
Yes, sir.
So
Okay.
that is the only difference. Okay. So you see that if you so if I multiply some minus thing here, okay, if I multiply minus thing here, then individually it will change the, suppose alpha is negative, right? If alpha is negative, then what I will get? If I multiply here, what I will get? Alpha cos 1 by x is less than equal to
0 minus
minus alpha, right?
Yes, yes.
And if I multiply same thing, if I do the same thing here, alpha is less than alpha cos 1 by x, right?
Yes,
and
sir.
now if I combine these two things, this thing and this thing, what I will get? Alpha is less than alpha cos 1 by x is less than minus alpha, right? So the same thing will happen here if you direct multiply alpha, right? It will simply change the order, right?
Okay, sir.
The order of the inequality. Right?
Understood, sir.
So yeah, you can try by splitting the inequality into two parts.
Okay, sir.
Yeah.
Thank you.
Sir, I have a doubt. Can you use sandwich theorem if the function is x cos 1 by x?
Sorry, sandwich theorem?
Like instead of x square cos 1 by x, if it's x cos 1 by x, can you use sandwich theorem? Because you said about the sign, right? You said x square is greater than 0. That's why we can multiply. That's why.
No, that is the thing. See, when so when you have x square, right?
Yes, sir.
So you know that x is positive, right?
Yeah.
Correct or not? So, but when you have only x, right? When you have only x, right? So when you are coming from left hand side to 0, from the right hand side, in that case x is positive, right?
Yeah, x is positive.
But when you are coming to this 0 from the left hand side, in that case x is
Negative.
negative, right? So in that case you have to take two separate case, right?
Okay,
Correct.
okay.
Right? You can apply sandwich theorem, but in that case you have to apply separately. Okay. The first case when x is positive, right? In the second case when x is negative.
Okay, sir. Okay.
You got my point?
Yeah, yes, sir. So its limit does this the answer limit does not exist because for x equal x less than 0 and x greater than 0, you get different answers. Right?
Is it?
Yeah, sir. One would be no. Oh, because it's x tends to 0, I think it's the same answer.
Even in this case also you'll get limit as your, I guess, 0. Okay.
Okay, sir. Okay. Thank you, sir.
Yeah. Okay. So the next thing is continuity, and again, like once you know the limit, once you know how to compute limit, okay, then basically continuity comes free. Okay. So suppose you say you have a limit, right? Again, if limit doesn't exist, suppose you have a function if limit doesn't exist, then basically you say that at x equal to a, then from here itself you can say that f is not continuous. Right? If limit exists, and it's equals to the value of the function at that point, okay, in that case you say that f is continuous, right? So suppose you have a function like this. Let's say you have a function like this, right? And okay, so let me write what is this function. F of x equal to 1 if x is not equal to 0, right? It's -1 x equal to 0, right? So at 0, so this point is not included. Okay, this is the value. So tell me what will be the left hand limit for this function?
1.
1, correct.
1, sir.
Yeah, the left hand limit is 1, right? And what about the right hand limit?
1.
This is also 1. That means limit exists, right?
Yeah.
How,
So-
sir?
See, when I'm coming to okay, so sorry. I wanted to find at 0. Okay. No, still this is 1. Okay.
Yeah.
But this is 0. See, when I'm coming to 0 from the left hand side, what is the value? This is precisely approaching to 1, right?
1.
Yes, sir.
Yeah.
Minus 1, sir.
No, it's approaching to
Yes,
1.
sir.
1, right? And even when you are coming from the
From
right hand side, this
it
is
is
also
1.
approaching. But so as you can see, the left hand limit and right hand limit matches and they are equal, right?
Yes, sir.
Yeah, so in particular limit exists, but this is not equal to f of 1, right? Sorry,
Yeah.
f of 0, right?
0. It will be
So-
hollow.
Yeah, so in this case, this is not a continuous, even though it has a limit. Okay, even though it has a limit, this function is not continuous. So okay, in this there is a special name, so you say it's removal discontinuity, okay. Not continuous. Okay, because yeah, so this condition is really crucial. Okay, so if you need to check the limit, and after that you need to check whether your limit matches with the value of the function. Okay, then only you say that the function is continuous. Just don't stop here by just simply checking the limit. Okay. So I guess no, I didn't discuss this question. Yeah. So suppose you have a function like this. Okay. So this is if x is not equal to 0, then this is the value of the function, and if it is equals to 0, then the value of the function is 0. Okay. So tell me whether this function is continuous at x equal to 0.
Yeah. Continuous.
Yeah, yes, sir, it's continuous.
Yes, sir.
Yeah. How?
Continuous. Left limit would equal
le-
and right also equal.
Sorry.
Left limit and right limit are equal, but that exist, and also function.
Zero.
Yeah. How you are computing it? Suppose you are computing the left limit. Yeah.
So it makes a 0/0 form, which gives us 0.
No. How? See, if it,
0/0,
That
not
will
0.
be indeterminate form, no?
0 by 0 form will never be
Sir, in
0.
question itself, it's given x is equal to 0. At x is equal to 0, it's 0. So we can take it as.
So from see, this is given, the only thing you can say that f of 0 is 0, right?
Sir, we are
Yeah.
having absolute value and x will get cancelled and we will only get x. When we put the value for x, it will be 0. Limit will be 0.
Yeah, I'm saying why. See, you are basically bluffing. Okay, so you are still now, you are not giving me the answer.
Sir, when we
mod
put a minus 0 in the mod, it will give x.
Sorry,
So 1x will get cancelled with the x square.
sorry, x square.
Sir,
The
when
x
we will
square
put
you can
minus
write
x
as mod x
in
the
the
whole
inside the
square.
mod,
Just a minute. Just yeah, you continue. Huh? X square by mod x.
when we will put minus x, I'm saying when we are coming from the left side, so minus x square will be x square and minus of mod x will be x. So 1x will get cancelled with the square. We are only having x. So when we'll put the value, we will get 0. Both are same.
Again,
The
like
value for x and minus x is same.
Again, yes. So the idea is correct, but whatever you said, still it's incorrect. So
Actually, sir, it is indeterminate form, so we can factorize, rationalize, or Lopter rule. So we factorize, so or rationalize. Then
okay, yeah. So okay, let me stop. Okay, so
Sir, may I try?
yeah, you can. Yeah.
Sir, it's when x greater than 0, then f of x equal to x square by x, right? That gives us y equal to f of x equals x square by x when x greater than 0. That gives us f of x equal to x, right? That means if x equal to 1, let's say, so when we approach from right, then the limit approaches to 1, right? And when x less than 0, then f of x equal to x square by minus x. So that gives us f of x equal to minus x. So when we approaches from left, the limit approaches to minus minus x. So so that means limit doesn't exist, right?
But okay,
and
so
here, in that case, it is not continuous, right?
So here, as you can see, we are talking about 0, right? So you have x and you have minus x. In both the cases, it will go to 0, right? Whatever you said is correct.
Yes.
Okay, but the last argument is incorrect. So we are talking about x equal to 0, right? We're not talking about some different number.
Yes, yes, I understand.
Even though the function is whatever you said is incorrect for x equal to 1. At x equal to 1 also this function is continuous. Okay. Because see, when you are talking about 1, okay, when you are talking about 1, in that case, you don't have to consider the negative if x is less than 0, right? Why you want to consider? Because you have here, right? So
okay, sir.
So you can come to 1 by taking some positive numbers. So the only problem, this positive and negative actually comes when you are in the middle. This is precisely 0. But yeah, whatever you said is correct. Okay, this x.
The same equation will come for minus x also, x square by x, because it's mod in the denominator.
So yeah, correct. So the thing is, when you have 0, right? So this is your 0. When you are coming to 0 from the left hand side, right? So you are coming by using bunch of negative numbers, right? And if your x is negative, then what is mod x? Mod x is minus of x, right? So this I can write limit x tends to 0 negative x square by minus x, right? And this is nothing but limit x tends to 0 negative minus x, and this limit is 0, right? And so this is your left hand. Now, when you are coming to 0 from the right hand side, so then you are basically coming using some positive numbers. So in that case, your x is positive, right? And if x is positive, mod of x is precisely x. Okay. So again, if I apply the same method here, then what I will get? X square by x, which is limit 0 plus of x, this is 0, right? So my right hand limit is same as the left hand limit, right? So limit exists, and the next task is
Sir,
to
I
check.
have a small doubt, sir.
Just a minute. So the next task is whether this limit matches with the value of the function. Okay. So since this limit matches with the value of the function, so that's why the function is continuous.
Continuous.
At x equal to, yeah. So any problem with this question now you can ask.
So the mode will give us two values. One is positive x and another one is negative x. So we
see, mod x will always give you positive number. Okay. See, the thing is what, again, see, what basically I have written here. If x is negative, okay, if x is negative, then what I have written? Mod of x is minus of x, right?
Yes, sir.
So this is still positive. This minus of x is still positive, right? See, if x is minus 2, if x is minus 2, what is mod of minus 2?
2.
This is minus of minus 2, right?
Oh, okay.
This is x, right? This x is minus 2. So when you are taking the modulus, this is precisely minus of minus 2, right? This is actually minus of x, right?
Yes, sir. Yes, sir.
So that's why you have a minus number here. When you take another minus, you will get the positive, right?
Right, sir. Right.
So that's why when x is negative, mod of x is minus x. Okay. And when x is positive, this mod of x is simply x, right? Because if x is 2, then what is mod of 2? Mod of 2 is simply 2, right?
2, right, sir.
But when x is negative, if I write mod of x is x, then I will get 2, minus 2, right? Which is incorrect. So I have to take one more negative.
Yes,
right?
sir.
Minus of minus.
So it is minus of x.
Yeah. So that is what I have written here. If x is negative, this is minus of mod of x is minus of x. Okay. And
Understood, sir.
X is positive, mod of x is x. You have to do two separate cases. Anything else from this question?
No, sir.
So one doubt, sir. So if this question has been changed, like if x is not equal to 1, and then x is equal to 1, the same value, like x square by mod of x, if x is not equal to 1, and 0 if x is equal to 1. So the limit exists. Yes, sir. The limit exists, but it is not continuous, right?
Where?
In case of the left hand limit and the right hand limit will tend to 1, right?
No, you are talking at x equal to 1, right?
Yes, sir, correct.
You want to find, so in this case, you want to find the limit of the function at x equal to 1.
Correct,
right?
sir. Correct.
So one thing, let me tell you, you can see, right? This function is undefined at x equal to 0. Okay. Again, this will certainly not play any role to find the limit of the function at x equal to 1. But okay. So I just want to point it out that if you define like this, can you see this function is not defined at x equal to 0? Because it's at 0, it will not give you any value, right?
Yes, sir.
But still, again, it's not going to create any problem to find the limit of the function at x equal to 1. See, at x equal to, if x is not equal to 1, okay. So as you can see, the limit of the function is left hand limit. So this is x square by mod of x, right?
Yes, sir.
So if I have 1, right? So this part is positive, right? This part
Yes,
is
sir.
also positive. This part is also positive. Okay, so I
Yes,
am
sir.
precisely in the positive part, right? So
Yes,
in
sir.
both the cases, mod of x is actually x. Okay, so this is, so in some sense, in this small neighborhood of 1, this is precisely x, right?
Yes.
So both left hand limit and right hand limit, they are 1.
Yes,
right?
sir. Mm.
But the problem is they don't
At
match. Yeah, so they don't match with the value of the function, right?
Correct, sir.
So the limit exists, but this is not,
But it's not continuous.
continuous.
Oh,
Yes, yes.
yes, sir. Got it. Thank you, sir.
Yes. Thanks. Okay, so yeah, so the next question is this one. What about this one? How I can find the limit of this function?
Sir, left hand limit not equal to right hand limit.
That is probably correct, but I'm asking why? How you are getting that?
Sir, 1 by x, like 1 by x tends to positive infinity when x tends to 0 plus.
Just a minute, let me write. So this is 1 by
You raise to 1 by x plus 1.
0. This is the function. So my first task is to find the left hand limit, right? How I can get the left hand limit? So left hand limit means x is going to 0 from the negative side.
Yeah.
So
1 by x.
denominator part, if it takes limit 0, then denominator part become 1. So left hand limit will become 1. And
see again,
right
you
hand
are
limit
basically
is 0.
throwing me the answer. Okay, I am asking the steps. Okay, you tell me the steps, how you are getting. Okay, so if you direct tell me the answer, it's basically from activity question, right? So if you direct tell me the answer, then there is no point. Okay, you need to know the method. Okay, tell me the steps.
Sir,
Yeah.
1 by x tends to minus infinity.
Correct. So as you can see, so let me tell you why. So this is your 0, right? So when you are coming to 0 from the left hand side, right? So this is negative numbers, right? So you are coming to 0 by very, very, very small negative numbers, right? So that means suppose you have 0 minus 0.1, okay, minus 0.001, minus 0.00001, you are coming to 0. So if you take the reciprocal of all this number, then it will go towards minus infinity, right? 1 by x will go towards minus infinity. Yeah, then the next step, what will happen?
E raised to 1 by x will go towards 0.
Correct. E power 1 by x will go towards 0, right? Because 1 by x is going towards minus infinity, right? So then what will happen? This e power minus infinity, it will go towards 0. And as a result, so you can say that 1 by e power 1 by x plus 1 will go towards
1 by 1.
1 by 1, which is 1, right? So the left hand limit of this function is 1, right? And what about the right hand limit?
X tends to 0 plus 1 by x tends to
Positive.
Correct. It basically goes to infinity. In that case, 1 by x will go to infinity, and your 1 by e power 1 by x plus 1 will go to 0. Okay, so it's clear, both the things, they don't match, right? So this function certainly it's even not here, even the limit doesn't exist, right?
Yes, sir.
So the limit doesn't exist. So forget about continuity. Okay. And can one of you tell me how I can solve this one? So this basically solves all
Yes,
this.
sir. Sir, we can take range of e to the power x and then add 1 and then reverse it. Reciprocate basically.
Again, so yeah, so again, sort of vague answer. So can one of you tell me more precisely?
Sir, e to the power x range from 0 to infinity.
Right?
Yes,
Correct.
sir. And if we add 1, then it will range from greater than 1.
Yeah, so if I can write this, then basically I can write this as well, right? Correct?
Yes, sir.
Yes, sir.
So then I can write correct?
Yes, sir.
So this I can then, after that, if I take the reciprocal,
Still greater than 1.
not still greater than 1. How?
Yes, sir.
See, if you take the reciprocal, then see if
The
this
sign
is
changes.
not, yeah. So in some sense, this inequality changes. Okay. Reciprocal will not change the sign. It will change the sign of the inequality.
Okay, sir.
And also, you know that this is greater than 0, right? So it's basically in between 0 to 1. Okay, the value of this function is precisely in between 0 to 1. Of course, when x is not equal to 0. No, because at x equal to 0, the value of the function is 0. Okay. So yeah, so this basically tells you that the function is bounded. Okay. Clear? Any doubt from this question number 7?
Sir, can you just show the right hand limit part?
Yes. You want me to repeat?
Yes, sir, please.
Yeah. So see, the thing is what, you understand the left hand part, right? So if you have 0 here, what is happening? You are coming to 0 from the right hand side, right?
Yes, sir.
So you are coming using some positive numbers. Let's say again 0.1, 0.001, 0.
Yes, a positive infinity.
Yeah. So then, so some positive number, right? If x is going towards 0 plus, then 1 by x will go towards positive infinity, right? If 1 by x is going towards positive infinity, where this e power 1 by x?
Infinity, sir.
Infinity, right?
Right, sir.
So that means 1 plus e power 1 by x is still going towards infinity.
Yes, sir.
Right? And if I take the reciprocal, okay, where it will go towards
0.
0.
Yes, sir.
So then this is precisely the right hand. Okay.
Understood, sir. Thank
Yes,
you.
yes. So okay. Okay, so the last.
So can you also tell the bounded part again? Sir?
Yes, I was also about to ask the same thing.
Okay, okay, just a minute. See, the one thing I know, e power x is greater than 0, right?
Yes, sir.
For all x.
Yes.
Let's say I can write this as well, because this is true for all x, right? So in particular, this is true for all non-zero x, right? If this is the case, I can write this thing, right? Any problem from this step?
Yes, sir. I want to ask, sir, you put r minus 0. So for 0 also, x, if x is equal to 0, it will be 1, right? So it will be again greater than 0.
But again, see, the thing is, if I write 0, okay, then I can't write 1 by x, right? So that is the only reason I'm not writing 0 here. Okay. See, if I write actually 0, okay, so then this 1 by x is not defined, right?
Okay, okay, got
I
it.
just want to avoid that feature.
Okay.
So this is true, right? See, so from this step to this step, is it clear?
Yes, sir.
Yes, sir.
In essence, e power anything is positive value, right?
Yes.
Okay.
So once this is true, then again, I guess the rest things are routine check. Okay, so
yes, correct, sir.
So then you just take the reciprocal, right? It will just change the sign.
Okay. Yes,
And you know all these things, the whole thing is positive, right?
yes, sir.
So this is true if x is not equal to 0. And you know, if x equal to 0, the value of the function is what? 0, right? So, so
yes.
in particular, your f of x is in this interval, right? For all x in R, right?
Yes.
So this is in a bounded set, right? So that means
Yes.
your function is bounded. Okay.
Got it, sir.
Yeah. Okay, so
Thank you, sir.
yeah, so this is all about continuity. Let's move to the last part. Yeah, so
Sir, can I ask one question? It's about bounded and unbounded. There is a question in activity 8.1, question 5. Can you explain third and fourth option in that?
8.5.
No, 8.1, fifth question.
Yeah. You are talking about in this particular question, you are talking about option 3 and 4, right?
3 and 4.
Yes. So the 3 and 4, the option 3 says what basically it's saying, there exists a non-constant continuous function from R to R, which is bounded. Okay. So it's saying there exists a non-constant continuous function from R to R, which is
bounded.
It's basically asking whether this statement is correct or not, right? So if you are saying this statement is correct, then what you need to show? You need to provide an example, right? If you can provide an example of a function, continuous function from R to R, which is non-constant as well as bounded, okay? In that case, you can say this statement is correct. And if you want to say that statement is incorrect, okay, basically, in other words, you are saying there exists no such function, no such continuous function from R to R, which is non-constant and as well as bounded. In that case, you have to prove it. Okay. So it turns out that this statement is correct. Okay. So you can have a function from R to R, which is non-constant as well as bounded. Do you have any idea?
So can we take x is equal to y? And we can define the like boundary.
X equal to a y.
Yes.
What is that?
So like it's an increasing function.
Sin x. Sin x, right?
Oh, okay.
It's basically if you take f of x equal to sin x, right? This is non-constant, right?
Okay.
This is certainly not a constant function. And as well as this is bounded, right? Because sin x is in between 1 to n minus 1. Right? Even you can take cos x as well, right? And yeah, so if you want to take, let's say you take x square by x square plus 1, right? This is a non-constant function, and as well as this is also bounded, right? Because you have a bigger number in the denominator, right? X square plus 1 is always greater than x square, right? That means x square by x square plus 1 is always less than, and also this is always positive, right? Greater than or equal to 0. Not positive, greater than or equal to 0. So this is also a continuous function as well as bounded, right?
So, sir, we cannot define our range and decide, right? We have to check with the existing one, like for all, where all the values exist, right?
This is exists for all the values
it
of
exists for all values, yes.
yeah. So it's not going to create any problem. It's a continuous function from R to R.
Okay.
See, the problem is if I take, say, let's say x f of x equal to x by x plus 1, then I am in trouble because I have x. So this is not defined at 1, minus 1, right?
Minus 1, yes.
So that's why that's the only reason. That's why I took x square. Okay, if I take x square, then it's not going to create any problem because x square is always positive. Okay. So I'll never get 0 in the denominator.
Sir, what will happen if we take fx is equal to 10x?
10x is not bounded, right?
It won't.
Okay.
10x
can vary.
If you are taking f of x equal to 10x, f of x equal to 10x, this is a straight line, right?
No, tan x, sir.
Tan x.
Oh.
Yes, sir.
Tan x is not defined on whole R. Okay, first of all, this is not bounded function. Okay, tan x. See, if you draw the graph, okay, so tan x is not defined at pi by 2, right?
Right.
So first of all, this. So what is asking whether there exists a function from R to R, right? The domain should be R. So in this case, first of all, the domain is not R. Okay. Even if you take in a fixed domain, right? Let's say pi by 2 to minus pi by 2 to pi by 2, right? So in that case also, this is not bounded. Okay. So if you take, actually, this is a asymptote. For this function, this is asymptote as well as this is asymptote. So you will have a graph like this.
Yes, sir. Okay. It moves infinity.
Yeah. Okay, in both the direction, actually. In the
yes, sir.
It basically goes to minus infinity as well as plus infinity. So tan x is not a good choice for this.
Okay, sir.
So whoever asked this question now, is it clear?
I got it.
Yeah. So this is second option. Okay. So the next option is this is third option. The fourth option is there exists a unbounded continuous function from 2, 3 to R. Okay. So the next option says there exists a unbounded continuous function from 2, I guess, 2 open interval, right?
2 open and 3
close to R. So what you want? You want a map. Is asking whether you have a map from here to here, which is continuous and as well as unbounded. Any idea? You have seen this type of function, you have seen many times. Okay. So the only thing is you need to
we can draw the same line like we've seen the tan function.
Yeah, you tell me the precise, you should able to tell me the precise formula for such type of function.
Y equal to x plus 1.
Y equal to x plus 1, how? See, f of x plus 1, if you take f of x plus 1, right? See, if you consider this as a function from R to R, okay, in that case, this is bounded and unbounded, right? But if I restrict my domain to here, right? See, the maximum value x can take is 3, right? That means this is always less than 4. Okay, and the minimum value that x can take is 2. That means this is always greater than or equal to 3, right? So this is in between 3 to 4. This is a bounded function if you restrict your domain to 2, 3. So yes. This is not a example. See, I want an unbounded continuous function, right?
So x by x minus 3.
X by x minus
3.
See, okay, you are more or less correct, but if you take x by x minus 3, right? So 3 is not in the domain, right?
So 3 is domain.
3 is not inside the domain, right? If you put 3, what you will get? You will get 3 by 0, right? Which is not defined. So what you want? See, the only advantage is this 2 is not in your domain, right? But 3 is in your domain. Okay. So instead of 3, you can put 2. Because 2 is not going to create any problem because 2 is not inside the domain, right? Because by definition, 2 is not inside the domain, right? So I cannot put 2 here. Okay. So that's why it's not going to create any problem.
Okay.
But as you can see, if you are coming to 2, okay, if you are coming closer and closer to 2, this is actually going closer and closer to 0, right? As a result, the whole thing will go towards infinity, right? So this is a unbounded function and as well as continuous. Unbounded plus continuous from here to R. Okay. Is it clear now?
Yes, sir. Yes, sir.
Okay, fine. Okay, so so the next thing is what? Differentiability. So yes, so can you tell me what is the definition? How you check the differentiability of a function? At suppose I have a function from R to R, and how I'm going to check the differentiability of the function at x equal to a.
Sir, before starting differentiability, the differentiable and derivative are the same things.
Yeah, so again, see. See, derivative of a function at some point. Okay, so derivative is sort of a in what sense? It's basically sort of a value. Okay, the derivative of sine x is cos x. Okay.
Yes, sir.
But differentiability is a property. Okay, I say that sine x is differentiable. Okay. So derivative is eventually they basically tells you the same thing. Okay, but if I ask you whether this function is differentiable, okay, so that basically asking whether this function has this property or not. Okay.
Yes, sir.
But when I ask you when I ask you what is the derivative of sine x, then your answer will be
cos x.
Cos x. Okay, but if I ask you whether this function is differentiable or not, I am asking about the property.
Yeah, the f of f a plus h minus f of a divided by h exist or not.
Yeah, you tell me formally. Yeah, so so when I can say that this function is differentiable at x equal to
so it at x equal to a, it will
limit h tends to 0.
H tends to 0, f of f bracket a plus h minus f of a divided by h.
Right? If this limit exists,
then function is differentiable.
If this limit doesn't exist, the function is not differentiable.
Not differentiable.
And the thing is, so again, so there are two things to understand here. So so when actually, so geometrically, when you say this function is not differentiable, when you have some kind of corner point, right?
Yes, sir.
So if you have suppose you have a function like this, right? So as you can see, this is sort of a corner point, right?
Yes, sir.
So in this case, this function is, if this is my point A, then I can say that by just looking at the graph, I can say that this function is not
differentiable,
right?
Okay.
Because again, if I compute the reason is, if I compute the left right hand derivative, okay, then this will give me the slope of this line, right?
Yes,
sir. Give me the slope of this line. If I compute the left hand derivative, this will give me the slope of this
another line. Yes.
So that's why this is one of the reason when you have a V shape, okay, or some kind of corner points is there in your graph. In that case, the function is not differentiable. Okay.
Yes, sir.
So,
Sir, but it may be continuous.
yeah, it can be continuous. Yeah.
Okay.
This is continuous. So, for example, if you have a graph like this, let's say you have a graph like this. Okay. So in this case, what is happening? This is not continuous, right?
Yes, sir.
So since this is not continuous, from
It is
there
not
itself not differentiable at this point, right?
Yes, sir.
So continuity is actually essential. Okay. So if the function is not continuous, I can always say that my function is not differentiable. Okay. So,
yes, sir.
But the converse is not correct, right? So if I take this function f of x equal to mod x, as someone already said. So if I take this function, so if I draw the graph, of course this is continuous, right? Continuous at x equal to 0, right?
Yes, sir.
But the problem is this is not differentiable at x equal to 0, right? Because if you compute the right hand derivative, then this will precisely give you the slope of this line, right? And if you compute the left hand derivative, this will give you.
So we can also say that it is not differentiable because it doesn't have a unique slope.
Not unique slope. There is no concept of unique slope. Okay, so better to say there is no unique tangent. Okay.
Okay, sir.
Yeah. So unique slope. Okay, so this sort of mostly we don't use this terminology very often. Okay, so you can say that there is no unique tangent.
Tangent. Okay, sir.
Sir, but tangent means slope, right?
No, tangent.
In any given point, if we take sorry, but tan theta, right?
Yeah,
rise over run.
Tangent doesn't mean slope. Yes, but again, like if you have a tangent, then you can talk about slope. See, this is just a terminology. Okay, we don't see you can, like, there are a lot of different names, but most of the time we don't use all these names. Okay, so it's all about that. Okay, so yeah, so continuity is essential for differentiability. If a function is differentiable, that means this is continuous, but the converse is not. As I said, this function is continuous at x equal to 0, but still this is not differentiable at x equal to 0. Okay.
Excuse me, sir. Sir, if the point lie on the end of the curve, then will it differentiable?
Where is the end? Where is the end? Can you show me the end?
Sir, if the range is given and like mod x, so if the end is given, so at the end of curve, like it's not a curve, it's a what we say, it's a
differentiable
sharp point. It's a sharp point, right?
Where? So you are suppose you are taking the range, right? Let's say you want to
define fixing the domain from 3 to 3.
That is, let's say you fix the domain 3 minus 3 to 3.
Minus 3 to
3. Yeah. So what is the problem here? So here you don't have any right hand derivative, left hand derivative, right?
Yes, sir.
You just have only right hand derivative, right? So in that case, this is differentiable at minus 3. Okay. Because I don't have anything beyond this side, right? I don't have anything after this, right? But here the problem is the corner point. Basically, the thing I have something from the left as well as from the right. Okay. But yes, when you talk about this, okay, when you talk about this, so this one is going to be the tangent. Okay. This one is going to be the tangent. You don't have any other possibility because you don't have anything from the left. So in that case, this is differentiable at -3 as well as -3. Okay.
Okay, sir.
Yeah. Okay, so so yeah, so this again, this also you have done it in your activity. So suppose this is your function, okay. It's a piecewise function, and it's given that f is continuous and differentiable at x equal to 1, right? Then basically you need to find the value of k minus 2l plus n. How you can quickly, can one of you tell me how to solve this question?
So by using it, f is continuous, so we will find the one of the variable like k or l by putting them equal, just by getting the left hand limit and right hand limit, because it is continuous.
Correct.
And the differentiable part at x, we use the property. After that we get the another variable like k or l, whichever we don't get, and then we just put it in the equation.
Correct. So again, like, see, just first you need to use this property continuity. Okay. So again, I guess I have discussed this question, so let me quickly go through it now. So the left hand limit is basically k plus l, right, at x equal to 1. And
yes, sir.
The right hand limit is l
Equal
plus k plus
m,
and this should be equals to f of 1, which is k plus again l. But again, I have already k plus l, so I can ignore. I don't need to write the same thing twice. So from here I can get that m equals to 0, right? So this is what I can get from the continuity. Okay. So next is if I take sort of derivative. Okay. So then this should 2x if x is less than equal to 1, then
2lx plus k,
right? If x
yes,
is
sir, greater than 1.
So now again, the left hand derivative and right hand derivative should match. So the left hand derivative is 2k and the right hand derivative is
2l plus k.
2l plus k, right? So as a result, what I will get, 2l minus k is 0, right?
Yeah.
So now this is 0 and this is 0. If I add both the things, you will get 0, right? So the answer is 0. Okay, so yeah. How many questions are there? So one more question. So question number 9 basically says you need to pick the correct options. So tell me, what about
First option is incorrect.
First option is incorrect.
There is no minus sign.
No
yes,
minus.
sir. Cos will give minus sin x.
Okay. Yeah. The prediction is certainly it's correct, but let's try to find out the actual derivative. Okay. So if I take the derivative, what I will get?
Derivative of sin x, the remaining part same.
Cos of 2 cos 3x.
After that, we will get the derivative of the bracket part,
which is times 2 times
minus 6
and 3x.
sin 3x.
minus sin 3x, and then we will get the derivative of 3x, which is 3.
Correct. So this is the derivative of this function. Okay, and as you can see, this is not same as the one which is given in the option, right? So
yes, sir.
So option 1 is incorrect. And what about option 2?
Option 2 is correct.
Correct, sir.
If we take f of 2, that is equal to 4 plus x square.
Yeah, so if you see the question, what basically it's saying, h of x is the derivative of the function, right? That means f dash of x is h of x, right?
Yes, sir.
And if you take this thing, limit m tends to 0, f of 2 plus m minus f of 2 by m.
F
This is
dash of 2.
right. This is f dash of 2, right? And which is precisely h of 2, right? And what is h of 2? H of 2 is nothing but 4
Plus e square sine 2 pi plus
pi
2 pi plus e to the power 2.
And you know that this is 0, right?
0. 4 plus e square, which is same, so it is correct.
And what about this one, option 3?
Correct, sir.
Why?
Because it's differentiable at all real lines.
Sir,
if we take 0, it is differential at this also. So correct.
The solution part, I don't know how to solve this.
But you remember the answer, right?
The answers are given by someone else, not by me.
Okay, sorry. So yeah, so tell me, whoever said you again, like, see, I am asking why this function is differentiable on R, and you are saying this function is differentiable on whole real. So this is not the correct way of answering this question, right?
So we can find f dash of x.
Yeah, so you can find, yes, it's correct, but before that you have to make sure that the function is differentiable, right?
By putting fx in the definition of differentiable.
So when you can find the derivative, the first thing is
the function is continuous.
Not function is continuous. This function is certainly continuous. Okay, so what I'm saying, when you can make sure that you can differentiate a function, only
Sir, can we mention this as if x plus h minus fx by h, like x plus h divided by ex to the power h minus this, if that exists, then we can tell it is differentiable.
See okay, so
that's a principle.
Do you remember?
Basic,
do you remember the product of two differentiable function is differentiable?
Yeah, we know that.
Yeah, so
Okay. So x and e raised to x are differentiable.
Okay.
So this is what?
X into e to the power minus x, you can write.
E power x, right?
Yeah.
So x is differentiable, right?
Yes, sir.
E power x is differentiable, right?
Right.
And e power x is never 0, right? That
right,
means 1 by e power x is differentiable, right? So 1 by e power x is differentiable, x is differentiable, right? That's why the product of two function, differentiable function, is differentiable. Got it?
Sir, to check the differentiability, we have to put 1 by ex in the property, right?
No, can you repeat to check the
differentiability of 1 by e to the power x? We have to put in the property of limit s tends to 0 f a plus h minus f of a.
Certainly you can go by the definition, okay. But you know the property, right? If f is non-zero, right? If f is non-zero and f is differentiable, then you know that 1 by f is also differentiable, right?
Okay, sir.
Again, like to prove it, you have to go through the
definition.
Okay.
Okay, sir.
But I'm assuming if you know that, okay, from there itself you know that e power x is differentiable. Again,
Right.
to tell e power x is differentiable, you have to go through the definition.
Okay, sir.
Rather, this function also, as I mentioned, sir, x plus h by e x plus h, that also you can do, but it is not required, as you rightly mentioned. It is product of two differentiable functions, so it is differentiable.
Yes.
Right.
Sir, can we say that if a function is differentiable, then its derivative will lie on that range domain? That if this function is differentiable on R, then its derivative will lie for whole R, right?
What do you mean by that?
Sir, I mean that if we have to find that this function is differentiable on R, then we can simply find its derivative and check that for whole R the derivative lies or not.
Yeah, so again, see, the thing is, that is what I was trying to say. Okay, so it's, and when you can talk about the derivative of a function, when you can talk about the derivative of a function, first you have to make sure that the function is differentiable, right? If the function is differentiable, then only I can talk about the derivative. Okay, I'm simply asking whether the function is differentiable or not. But what, instead of what you are saying, you find the derivative. How I can find the derivative if I don't know if the function is differentiable or not? Okay, so first I have to make sure that the function is differentiable. If the function is differentiable, then only I should try to find the derivative of the function.
I think,
So,
sir, he is asking like the domain remains same for the f of x and f dash x.
Yeah, the domain. See, if you say that from f is differentiable on R, right? That means f dash of x actually exists for all x in R, right? Right. So in that case, f dash of x is precisely, it's a map from R to. But again, this is not going to give you the answer of this question. Okay. What about the last option?
It's correct.
Correct. Why?
No, sir, it
So
is
it's
not.
the reverse. Okay.
If it is correct, why? If it is not correct, also why?
So it's not correct. Sir, may I try? Sir, let's say x is differentiable x equal to 0, and 1 by x, but 1 by x is not differentiable at x equal to 0. But if I multiply to x into 1 by x equal to 1, so f of x equal to 1, it is differentiable at x equal to 0, right? So if the product is differentiable, that doesn't mean the two functions separately are differentiable at any point.
Sir, I have one more example, x into mod x.
So then, if you take x equal to mod x, then what will happen?
So mod x is not differentiable at 0, but x mod x is differentiable at 0.
So your f of x equal to x time mod x, right?
Yes, sir.
What about your
Sir, x mod x will be an increasing function.
what about your g? See, it's saying the product of
No, I'm saying one is x, f of x is x, and g is mod x. Okay, 1 minute. Product is 1 minute. Product of two functions x, f, and g is differentiable.
So can we take fx equal to x mod x and gx as 1 upon mod x?
Oh, yeah, 1 upon mod x, then what? Actually, someone said 1 by x. The problem is 1 by x is not defined at x equal to 0. Okay. So when
the product of two functions like f and g is differentiable, that means x into the product means f and g is differentiable.
See, it's better.
Right? That means x mod x is differentiable. X into mod x is differentiable.
Yeah, most likely x mod x
yes.
is differentiable.
But sir, it is given that then both f and g are differentiable. But if you check, then x is different. Mod x is not differentiable.
Yes,
so
correct,
the statement is wrong.
Correct. Yeah. So if you take f of x equal to x and g of x is equal to mod x, then this f times g is nothing but x mod x. Okay. So this is differentiable, but this is not differentiable. Okay. And you can create a lot of examples. If you take mod x plus 1, let's say g of x equal to 1 by mod x plus 1. Then yeah, the product is actually 1. So the product is differentiable, but both f of x and g of x, they are not differentiable at 1. Again, like, yeah, so you can similarly you can create a lot of examples for which this statement is incorrect. Okay. Okay, so anything, any doubt from question number 9?
This sir, can you use the first principle for this particular product of two function? No, it's not derivable.
Sorry.
Product of two function f and g is differentiable, but f and g are differentiable. Can we prove this through this first principle also, that fx plus h? If I take,
see, that is actually different thing. See, the you are talking about the property. See, the property says slightly different. It says if f and g are differentiable, okay. If f and g are differentiable, then their product is differentiable, right? But in the question, we are asking the converse part. What we are saying, if the product is differentiable, then we are asking whether f and g are differentiable. Okay. See, the converse of this statement is correct. Okay.
Right.
If I write if f and g are differentiable,
right.
Then certainly f times g
yes.
is differentiable. Okay. This is a correct statement, but in this statement, I'm basically we're asking out the converse. Okay, if the product is differentiable, whether the individual function are differentiable, which is incorrect.
Okay.
So can we make a graph of functions like x times mod x?
Yeah, why you can't make? Try to plot in Desmos. Even you can
only in Desmos, like without that.
Without that also you can make, but you have to put little more effort. Okay, but
can you show the differentiation of x mod x, like how to do it?
Okay, let me okay, so this is again, this is, I guess, still this is inside your activity question, right?
Yes, I was a little confused there.
Yeah, I'll come to that. Just let me know once I finish, because this is the last question. Once I finish this, just let me know. This is easy. Okay, so the thing is, you just need to split this thing. Okay. This is x square minus x square. Okay. If x is greater than equal to 0. Okay, once you write, actually you can do it. Okay, I'll come to. Okay, so probably the last thing. If you have a function, let's say you have a differentiable function, then the derivative is precisely, it will give you the slope of this line, right? This f dash a is precisely the slope of this line, right? So how I can get the equation of this line? What is the equation of this line?
F dash a into x minus a plus fa.
Yeah, so by applying, so the only, you know that this line passes through this point, okay, and as well as the slope of this line is f dash a. So if you try to apply the methods, then what you will get? Y equal to
mx plus c.
Yeah, mx plus c, but I don't want to compute everything. You just tell me the final answer. What there is a
F of
right?
f dash a into x minus a plus f of a.
X minus a
plus
f of a.
Yeah. So if you compute by applying this slope and point formula, then you will get this equation. Okay. So yeah. So the derivative is why this is in some sense it's crucial, because this will give you the approximation of a function, linear approximation of function at that point. Okay, so and how we are getting the linear approximation? By computing this tangent line, because at this point, some neighborhood of this point, right, this tangent line is very close to this graph of function. Okay, so let me solve one question related to this. Okay, suppose you have a function which is differentiable at x equal to a, and of course this a is represented by some curve. So if a line passes through 5,8 and is the tangent to the curve at c at this point 1, 0, then what will the value of this f dash of a? It's easy. One of you can help me to solve this.
Answer is 2, sir.
Yeah.
How we solve it? Sir is asking that.
We can find the slope of the tangent, and the slope of the tangent will be the same or on the curve that is asking at x is equal to 1.
So okay, so this is your f, right? So it's saying so you have a line. Sorry, this is okay. This is badly drawn, but okay, consider this as a line. So it's saying this line passes through 1, 0. This is basically a tangent line. Okay, at 1. So this line passes through 1, 0 as well as 5, 8, right? So I know that the slope of this line is precisely f dash of 1, right? So and it's already given that this line passes through 2 points, right? So the only thing you need to know, you need to find the slope of this line. Okay, and that you can, right? 8 minus 0, 5 minus 1. Okay. Okay, so let me come back to this question. How I can find the derivative of this function. So I guess I already gave you the answer. So, and the same argument I'll use here. If x is greater than 0, then mod of x is what? It's x, right?
Yes, sir.
So as a result, see, one thing is clear, right? This function is differentiable at all non-zero real numbers, right?
Yes, sir. Yes, sir.
That is more or less clear. The only problem is at 0, right?
Yes.
So we just need to check whether the function is differentiable at 0, because apart from 0, it's basically it's x square and minus x square, which are differentiable.
Yes.
So
Got it. Thank you.
so do you want me to compute at x equal to 0, or you
No,
have
sir. I was confused at this point, so I got it.
Yeah. Okay, fine.
Thank you, sir.
Yeah. Okay, so this is what I have prepared. If you have any,
why it is minus x square when it is less than 0?
Because mod of x is minus x. Okay. If x
but it is also okay. But it is x is also there, sir. That will also be minus.
No, if x is negative, then x is x. Okay. If x is negative, mod x is minus x. Okay. I am not going to repeat this thing. I have repeated the same thing. Maybe if you see all the session, maybe at least 4 or 5 times.
Sir, one which is multiplied before the x, I am just that also will become minus.
Which one?
The one which is multiplied before the mod x.
This one, x.
Yes, sir. That will also be like minus when x is less than 0.
if x is less than 0, okay, you are saying x is minus x.
Yeah.
Why?
Well,
if -2 is less than 0, then you are saying -2 is minus of -2, which is 2. So -2 and 2 they are same.
oh, okay, sir. Okay, I think.
No, you try to spend some time. Okay, so what I'm saying, see,
yes.
If x is, I'm just saying if x is less than 0, mod of x is minus x. Okay.
Yes, sir.
Mod of x and x, they're two different, right?
Okay.
So I am only concerned about this thing. Okay, x is certainly equals to x. How you are going to change x?
Oh, yes. Okay.
Yeah. Okay. Any specific doubt or?
Sir, I have one doubt, sir. In the graded assignment, the last question I was not able to get it.
Which?
8th week, sir.
Graded assignment, question number?
The 10th question, sir, where you have a laboratory for the bacteria culture of type A. That one, sir.
Sir, the recording of this video is available, right, sir?
It is on YouTube.
Okay.
This is graded or practice assignment?
Graded, sir. The last one, sir, where you have two cases, P of T and Q of T. So I was not able to crack this question, sir.
Have you checked the solution?
Yes, sir. So from my understanding, they have asked, like, in the question, LP of T is equal to AT plus B. So I have to take the condition only for P of T, right? And they've given the point T is equal to 1. So only for that case, I have to find the value, sir, or?
Just a minute, let me open. This is the question, right?
No, sir. Scroll down, please. No, sir. No, not this one, sir.
This is question number 10, right?
So,
I think the question is in week 6.
No, sir. No, not this question, sir. Can you go up? No, sir. Not 9th. Yes, sir. Correct, sir. Correct, sir. You are right. 8th. Yeah, yes, sir. Correct, sir.
Which
P
question?
of T. P of T is T cube minus 27. So that is the question, sir.
No, what you want to know in this question?
So here, like in the graded assignment, week 8, 10th question, they've given if LP of T is equal to AT plus B. Is denotes the best linear approximation of the function P of T at the point T is equal to 1. Find the value of 2A plus B.
So basically you need to find the tangent, right? Of
Yes,
the
sir.
function at T equal to 1. Right?
Yes, sir.
So
So here they've specified it as LP of T. So I should take only P of T and then find the value of T is equal to 1, like where it fits.
no.
Sir, linear appropriation means we have to find the tangent.
Tangent, right? So you need to find the tangent of this function. So what is basically saying? Donate the linear approximation of the function at QT, right?
QT, okay.
So for this function QT, okay, you need to find the equation of the tangent line of this function QT at point, for your case, at point T equal to 1. Right?
Okay, sir.
So you will get a straight line, right?
Okay.
then you compare with this L of t. Okay, so what basically I mean, so if something is given, let's say, so this is your qt, right? You need to find the equation of the tangent line at x equal to not x, at t equal to 3.
Yes, sir.
At t equal to 3. So it's given that LP of t is, let's say, e power, let's say, x plus b, right? So if your tangent line is, let's say, y equal to 2x plus 3, right? So that basically what basically means this. So if you write in terms of LPT, this is LP of t is what? 2t plus 3, right?
Yes,
so now if you compare, your A is what? 2 and B is your 3. You just need to add A plus B. Okay.
So there was one more question, sir. This is a different sum. Q of t is equal to mod of t into t minus 2 into t minus 4.
Q of t
is equal to mod of t into t minus 2 into t minus 4. Sir, I found the value, sir, but then the value for the sum was minus 10, but then I wrote it as 10. I don't know where I went wrong.
No, you are trying to find the value of the function at.
Okay, sorry, sir. The question continues as, if m is the slope of the tangent of the function qt at point t is equal to 3 by 2. Find the value m minus 27 by 4.
Okay, so you just need to find the value, then after that you can.
Yes, sir.
So at 3 by 2, right?
Yes, sir. Correct, sir.
So you have 3 by 2, right?
Yes, sir.
You have 0, you have 2, you have 4, right? Okay, I made mistake. This is let's say this is 3 by 2, this is 2, right? So if you substitute
Sir, can't we do like we can take out the derivative of qt and then substitute, then derivative of qt will be the slope, and then we can put the value of t in that. We will get the value, and then we can directly put in the equation what is it is given, and then we can easily find the answer.
Yeah, that is also like what I am trying to say is basically, see, 3 by 2, if you substitute 3 by 2 here, okay, this is basically 3 by 2, right? This is some negative number, right? Correct or not?
Yes, sir.
Yes, sir.
This is also some negative number, right? So
Yes, sir.
in the end, you are getting some positive number, right?
Yes, sir.
Yes, sir.
Because of mode.
Yeah, so this q of t, okay, in some sense, in some neighborhood of this 3 by 2 is precisely what? T minus t by 2, t minus t by 2. Okay. Now you try to take the derivative. Okay. You can differentiate this function, right? This is just a polynomial function, right? And you substitute by 3. You will get the slope, right?
So the slope will be positive, right? Because it is mod of that slope, right?
No. That certainly you can't say. See, slope modulus means the value is positive, right? The slope
yes,
is
sir.
how this function is. See, slope basically decides something else. It's decide the rate of change of the function, right?
Yes, sir.
So you can't say whether this slope will be positive or negative. You have to compute, right? You try to find the derivative of this q.
So, but this mod function, like, till where should I apply, sir? That was the doubt.
Sorry?
Actually. Like, you have this function inside mod, right? So till which part should I apply mod? Like I got confused with that because I got the answer,
No.
but then it was
No,
the negative.
still I don't understand. Till which part I will apply means what?
So like
Mode,
when
sir. Till which
this
part she apply mode?
so
See.
this function is inside mod, right? Mod of t into t minus 2 into t minus 4. So when I get the like I think the when I derive it, I mean, when I multiply it, you get t cube into something like there'll be 3 terms, right? So and then like I substituted 3 by 2 inside that.
You if you take the differentiation, what you will get? T
2t
minus
square or
t minus 2, t minus 4 plus t into t minus 4.
Only t. Plus t.
Plus t.
Plus t become 1. 1, sir. T become 1. Constant becomes 0.
T minus 2 into t. Right?
So we'll get finally 3t minus 12t.
3t
minus 12t.
12t. Is it?
Sir, I multiply this t minus 2 into t minus 4 into t, and then I took the derivative.
But you should get a degree 2 polynomial, right?
Oh, sorry, t square, sorry. 3t square. Sorry. 3t square.
Yeah. So now you substitute q dash of 3 by 2, right? If you substitute, then what you will get? 3 into 9 by 4 minus 12 into 3 by 2. So this is 27 by 4 minus
18.
18. Okay. So this is the slope of this function at 3 by 2. See.
But there also be a constant function, sir, plus 8 will be there.
Plus?
Yeah. Plus 8 will be also there, right?
But it will, in derivative,
t square
it
minus
0.
4t.
In derivative, it becomes 0.
No. I'm saying in the q dash t, there is also a term plus 8 is there. No? In q dash t, there will be also 3t square minus 12t plus 8.
Okay, I guess, yeah.
Yeah.
Maybe.
So now this thing is, so when you differentiate it, will it still be under mod or?
No. So that is what, that's why I computed, right? So so that to remove this modulus,
Yes, sir,
okay,
plus 8 will be there.
what I checked if I substitute 3 by 2, what I'm getting positive number, right?
Yes, sir.
So that means in the small neighborhood of 3 by 2, okay, this function is positive, right? Okay. So if this is positive, then you know, right? If x is positive, mod of x is x. Positive. Okay. Yes, so that's why instead of this mod, I can simply write this x. Okay. See, if I get a negative thing, okay, if I substitute some number, if you are getting some negative thing, then one negative sign will come here, because if x is negative, mod of x is minus x. Okay. And according to, you have to do the derivative. See, one thing you have to understand. See, this function is not differentiable everywhere. See, this function is not differentiable at 0. This function is also not differentiable at 2. This function is also not differentiable at 4. Okay, but this function is differentiable at 3 by 2. Okay. And
sir.
What sign? So when you remove this modulus actually, then it comes with a sign. And this sign actually, and how you can decide the sign? By finding the value of this function at that point. Okay. Since here this is positive, that's why I'm getting positive, because mod of x is x if x is positive. Okay.
Oh, okay.
Sir, when we say the function is not differentiable, like you say at 0, the function is not differentiable.
Yeah, see, the thing is, when you have some function like mod of x, right?
Right.
So mod of x, right? So mod
Yes,
of
sir.
x is not differentiable at 0, right?
Yes, sir.
So when you have a function like, let's say, mod of x plus 1, okay, so you check where this function is giving 0. Okay, so this is giving 0 at -1, right?
Yes, sir.
So then this is not differentiable
At -1.
at -1. So here, if you see, you have 3 cases, right? It's giving 0 at
Yes, sir. 0 at 3 places, at 2 and 4.
Yeah, so you try to, if you draw the graph in Desmos, then you can really see that this function is not, of course you can do it mathematically, but again you have to do a lot of calculation.
Yes, sir. Thank you, sir.
Yeah.
Did you? Thank you.
Okay.
Thanks a lot.
Okay, thank you. Okay, I'll stop the
Sir,
session.
I want to ask one conceptual question, sir. Just, sir, like for the e to the power x graph and a normal a to the power x graph, sir, is there any difference like in the properties, or it's same?
I didn't understand your question. Suppose,
sir, like we have studied the exponential graph, right? For a to the power, like a to the power x. Let's say the a is greater than 1. And e to the power x, that also goes from 1, 0.
So you are
Sorry, 0,
considering
1. So, sir, the properties will be the same for both, right?
Yeah, property in the sense depend what sort of property you are talking about. Okay,
Sir, I want to ask, is there any difference in like in this? Because e is like it's 2 plus, right? So it's greater than 1.
Yeah. So see, again, this is increasing and all these things. So if you ask whether derivative, see, the derivative of ex is same, ex, right?
Yes.
But if you ask the derivative, this is not a power x, right? This is x of ln of it, right? So when you are saying that property are same, so you have to specify what property we are talking about. See, if you ask me whether they are increasing, yes, I can say they are increasing. Okay.
So, sir, can you please tell us like where it is different? So
no,
that
it's
we have
there
a
are
good idea.
there are infinitely many property of a function. So so it's depend what you want, right?
So you can tell us as per our course only. Sir, in
Okay,
short.
so see, in most of the cases, actually, it will be same. So you consider the graph of a power x, right? So when you are considering the graph of a power x, where a is greater than 1, right? This also is similar kind of graph, right?
Yes, sir. Yes, sir.
So again, so the thing, so you have more or less the same property apart from probably differentiability. Okay. So I don't see any other difference, at least in this course. I don't see any other difference because this function is increasing. This function is also increasing.
Also increasing, yes.
So here the asymptote is basically x-axis. Here also the asymptote is x-axis. Here the x in y intercept is
1, 0.
0, 1.
Sorry, 0, 1.
This is also 0, 1. Okay. So
the only difference is their differentiability.
Yeah. So again, both the functions are differentiable. Okay. But this is actually the derivative of this function is itself. Okay. So whereas the derivative of this function is not itself. Of course, if a is equals to e, then they are basically same. But apart from that, the derivative is not equal to, see, this e power x has some unique property, right? The derivative of this function is itself. Okay.
So just now you said a to the power e. What is that? Can you tell that?
No, not a power e. I'm asking, like, see, if you take a equal to e, right?
Okay,
then they are basically
equally. Yeah, then it will be the same.
It will be the same. So of course I'm assuming that a is not equal.
Yeah.
So whatever property you are using, 1, 1, increasing, okay. So they basically share all this property, okay. But again, even both are differentiable as well, okay. But the derivative of this function is itself, right? Whereas the derivative of this function is not itself.
Yeah, I start seeing.
Yeah. So this is the probably one and one yeah, so one property that holds here but doesn't hold in this case.
Okay, okay, sir.
Yeah.
Okay, thank you, sir.
Yeah.
Excuse me, sir.
So the PDF of the live session in the Google Calendar cannot be opened.
Sorry?
So the PDF of live sessions are not opening, which are in the Google Calendar. Recordings are playing just fine, but the PDF is not opening.
Means the session, the TA session you are talking about?
Yes, sir.
Okay, I'll ask Supam. Okay.
Okay, sir. Thank you.
Yeah. Okay, I'll stop the session.
Thank you, sir.
Yeah,
Okay,
thank
you,
thank
sir.
you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
So will be the PDF of live session will be provided?